Hello, welcome back to my channel. Today we will be looking at question 9.45. An internal explosion breaks an object initially at rest into two pieces, one of which has 1.4 times the mass of the other. If 90, if 9,500 joules is released in the explosion, how much kinetic energy does each piece acquire? First step is to write down the relationship between the masses. Initially, we would have a block or an object that explodes into two pieces, mass 1 and mass 2, each with their own respective velocities. We know that one of the masses is 1.4 times greater than the other. So for this example, I will be saying that m1 is equal to 1.4 times m2. So that means that mass 1 is the heavier object and mass 2 is the lighter object. To solve for the kinetic energy, we know that we need velocities of each mass. So to find the velocity of each mass, or the relationship between the velocities, would be to use conservation of momentum. If it is an explosion, it's conservation of momentum. So because there is no velocity, initial velocity would be equal to 0. 0 is equal to mass 1 times the velocity 1 of block 1 plus m2 v2. So this is the momentum of 1, this is the momentum of 2. Solving for this equation, we will plug in our known masses here. We said that m1 is equal to 1.4 times of m2. So we can just substitute m2 right into the equation. So instead of m1, we have 1.4 m2 v1 plus m2 v2. We solve for v1 in this case, so v1 is equal to negative m2 v2 over 1.4 m2. m2's cancel out, and you will have a fraction, you will have a answer that is negative 5 over 7 v2. This we will use again later. Now we know that it's conservation of energy too, because 9,500 joules are released in the explosion, so it's conservation of energy as well. It's conservation of energy as this is this is the initial energy that breaks up into two kinetic energy values. So knowing that, we have 9,500 joules is equal to 1/2 m1 v1 squared plus 1/2 m2 v2 squared. To continue this question, we should plug in what m1 is equal to. m1 is equal to 1.4 m2. v1 is equal to negative 5 over 7 v2. We need to plug these equations into these terms here. So if we do that, we have 9,500 joules is equal to 1/2 times 1.4 m2 times negative 5 over 7 v2 squared plus 1 half m2 v2 squared. Simplifying the right side of the equation, we will get something like 6 over 7 m2 v2 squared. At this point, we realize that the kinetic energy of mass 2 is 1 half m2 v2 squared. We are trying to look for the kinetic energy of both the masses. We will use this relationship here to find its actual value. So if we want to find that value, we have 9,500 joules is equal to 1 half m2 v2 squared. 6 over 7. We want something that will give us 6 over 7 is equal to x times 1 half. Multiplying, solving for x, we get 12 over 7. So 12 over 7. These two are equivalent. They are the same numerical value, but in this case, we have this in terms of kinetic energy of the second mass. So if we could re-simplify this as 9,500 joules is equal to 12 over 7 kinetic energy of 2. Solving for the kinetic energy of 2, we will get approximately 5,500 joules. That will be the kinetic energy of the lighter mass. Because energy is conserved, no energy is lost to heat or friction or anything. So to find the kinetic energy of 1 is just 9,500 joules minus 5,500 joules, which should give us 4,000 joules.